we have the distribution for convolutional code. Alright, so previously we got to know we have the decoding. Decoding actually will be done by Turby algorithm. Therefore, we have actually we can have this, but in the following we'll have the encoding. Therefore, we have the parameter distribution. We have K. Alright, we have R and the others. And in fact, later we have the way to show the results. We have n equal to 2 and k equal to 1. So, follow the definition, k over n we still have the code rate equal to a half. Well, we want to have this design. Maybe you have a reason why this way. But at least we have the shift register. Initially, we have a constant 0 for D1 and constant 0 for D2. And here we have the input bit. And output bit, we have Y1 and Y2. So we have one parallel. So one actually we have a parallel, but we just have a single bit. And output we have 2. So we have 2 output bits. And later we have the input here. Alright, starting from 1. And the others. Well, I think maybe it's hard. I'm not sure for you. Actually, we have something wrong, but I did not know. Finally, they don't solve it, so we still continue. So we have 1, 1, 1. So look at this. If we have the first one, input B. So here we have a different one. So you can check the first one. 1, and here is 1. So 0. So it's 2, 0, 1, and 0. So we have a 1, right? 0, 0, or 1, 1, we will have 0. And here we have 0. And 0 again we have a 1. Oh, sorry, this one. Here we have a 1 and 0. So it's 1 again, right? Okay, so in the following, I try to have some. Actually, we have the shifted one. Maybe let me check this further. If so, then it will shift. So if I ask the individual to check the constant, maybe not really easy. So if we have 1 and next one, we will shift. So it's 1, and here it's 0. So 1, 0 again is 1. So 1 and 1. So this one is 0. So y1 is 0, right? And here we have 1, but this one is 0, so it's still 1. So apparently it's okay for the 2 parallel bits. So after that one, we have 1 and 1, right? Shift. So finish that, it will shift. If we shift right now, how about 1 again? So it's 1 again. So 1 and 1. So and also here 1. So 1, 1, 0, 0 and 1. So it's still 1. So here we have 1. And 1 and 1. So it's 0. Is it okay? So let me stop here to allow you to check and discuss for 2 minutes with your neighbors. So we are going to see get closer. We are going to see and get closer to have the discussion. So then we have 3 minutes. Of course, you can check the others. After now, I check to the third bit. So that's okay? So maybe let me check first of all. So first of all, I want to check these. For the first three bits, if you still have a question, raise your hands. 1, 1, 1 to have the corresponding two bits. If you have a question, raise your hands. If no, right now, switch from the first one to check the lower one. Still have the result for 1, 0, 1 at least. So check it further. 3 more minutes. Now you can check if okay for the upper one. Right now you can check the lower one. At least check 3 bits. me or you me. Alice, Sue, and Wendy, and Shen, and Gallus. Gallus, yeah. Simple one, Gallus, right? Thomas. For you, your name? Andrew. Oh, Andrew, okay. Fine. So, right now, let me check. First of all, try to nominate and check the results. Me, for the lower one, okay for you. For the first 3 bits, can you have the pattern 1110 and 00? Can you have it? Yes or no? Okay for you? Okay. Okay. Right? It's okay, right? Or maybe let me ask your partner. Jen? Good. And the wedding? And Andrew? Your team? Okay for the first 3 parts. Yeah, that's okay, right? Right? Okay. And Jay? Wait. Still have some problem? Oh, let me check this. Maybe still have some problem. So first one, no problem, right? And second one, actually we shift. Here we have 1. But right now it's 0. So 0, 1, and 0. So it's 1. Right? Here we have 1, 0. So 0, 1, and 0. So it's 1. And here it's 1. Right? But we have 0. And 0 again. So we have 0. Alright. So shifting, so we have 1 and 0. 1 and 0, next one is 1. So 1, 0, and 1, so it's 0. And here we have 1. And this one, previously it should be 1. So 1. So of course we have 0. That's it. Of course you can continue to have the other bit string. So that's why this is a bit string, not the block. Previously I thought I want to let you determine the individual outcome. No, it's hard to have the outcome. For example here, you need to determine all the results and then you will check the final one. So it cannot be determined individually. Alright, that's it. So this is the convolutional encoding part. Well, and right now we have the content, and here we have the inner side, and we have the output one. If we have actually we have the here we have actually it should be D1, D2, and we have the others. But sometimes we have a diagram. If we have a diagram like the pattern, and we have an input, and then we will have output. So initially we have a 0, 0, right? And 0, 0 input 1 is 1, 1, right? Follow the previous one to show the diagram. Here we have D1, D2, so we have the stat. And stat is initially 0, 0. And if we have the input, and then it's 1, 1, right? Input, then we have the output is 1, 1. The output for Y1 and Y2. So here we have So we will change to 1, 0. Is it okay? If it is 1, 0, 1, 0, then try to have an input 1. So something like the first one. We have a 1, 0 to have an input 1, so we have a 0, 1, right? So the output it should be 0, 1. Right? So after now, we check the path here. Alright, we check the path here. But you need to check it further. So it's possible to have a pattern actually 0, 0, 0, 1, 1, 0, 1, 1. Correct. So these are all steps. And we have 1 and we have a 0. But how about 0? We don't have the derivation for 0, so you can check it. For the current one, if we check 0, 0, 0, and 0, so all 0, right? So all 0, output 0, but shifted, so still have a 0, 0. Alright, and for this, if we have 1, so we will go back to this, so no problem. But we want to, so this one, 0, 0, we have a 0 and 1, so finish. And if we have a 0, 1, to have an input 0, finally we will have output. Sorry, we will go to the step 0, 0. But what is the output? If we have a 0, 1 to have an input 0. We have a 0, 1 to have an input 0. So, what's the output? 0, 0, and 1. So it's 1 again. And 0, 1. So it's 1 again. So 1, 1. Right? So this one, check, check, and check, and check. Alright. So I allow you to take a picture. This one. So take a picture for these first. So this time it's easy. Here I have a label. I have a label 1, 2, 3, and 4. Right? 1, 2, 3, and 4. And this time I try to have the assignment to good 1 is 1. Good 1 is 1. And good 2, good 3, and good 4. And based on your diagram previously, right? Should register to check and allow you to have one presenter to check. But let me have the preparation for catalyst. So wait a moment. So you can check it. You can jointly discuss is it true. But all I ask you to do, you need to show me your content and show me the output why. So you can base on the photo there, but try to have something right on the photo, and so that you can have the output and put it to the catalyst. So wait a moment, let me check it. So right now you can check our line group and so that you can have the entry to the pattern, right? Of course, and then we have the two figures. And let me have the correction first. So that's it. I then have the assignment 1, 2, 3, and 4. And here we have the stat diagram. And right now, if you finish, then you can send your result. So good one, who will self-present. And presenter comes where we see 2 points of bonus. Good one. If yes, then use your count. Presenter use your count to post your result. And presenter to go to presenter. Jen, you want to serve it? Here. The second column. So you don't want? Okay, sure. Skip it. Or you. And good 3. Presenter. And good 4. Presenter. If yes, you are the presenter, then. So this is the result from yes. Great. So that's about the presentation by Get Us first. Get Us come to the front desk. And wait a moment. Which one you want to explain? Oh,
so we want to explain this one. Forward. Yeah. The idea is we have D1, D2 as 1 and 1. Our input is 0. So here we have 0, 1, 1. We
add 0.
We have 0 as I1.
Yeah.
Here we have 0 and 1, and we have 1 as I2.
Okay.
So this is for the data.
Okay. Sure. Good. So it's correct. Correct by Gareth. And last one. So this time, no need to show you are the presenter because here, your name here, right? I will ask TA to check, please. All right. And the next one. Good one. Finish there, you can pause here. And good 3. And good 2. Want to join or skip? And if you have it, then I allow you to have for the presentation. So you want to try? Use your count. Use the count of 2. So if you have the answer, then post it on this, and then we can let it have a presentation. If you want to show your result, try to get it done in a minute. Once finished, you can come to the front desk to check. So the current story is we have the diagram like this, but we want to have the state transition. And actually I checked some of those for you. And we have the actual one checked by Peters. It's correct. And the time checked by Sue. Sue, you can come here to have your reason why.
So I do
Is it okay?
okay.
So welcome. Speak louder. No, it's okay.
It's okay?
Okay, no problem. 我会看下声。
Oh, okay.
Here.
Good. So,
Your case.
Yes, in our case, the
thing
previous app is 1 so it's 1 and 1 in the previous in the register because it from previous input, and the newest input in our case is 1. So we get 1 and the other 1. So for the output of y1, we will get 1 plus 1, so it becomes 1. So this y1, and for y2 is the 1 plus 1, so it becomes 0. So the output of our case is 1, 0.
So correct?
Yes,
Sure.
in our case is the picture.
Okay. Alright, thank you. So no problem? That's it?
Yeah, no problem.
Thank you. So actually this is another microphone. Don't worry. You see, here, I have microphone here. So no problem, but speak louder. So, Doria? But the presenter is this one. She needs to be the presenter. I will ask here to check this. So, Doria, you just come here. To say something, no problem. I don't know, we have the presenter pass on the account here. So next time the presenter, just use your account. And this time it won't be necessary to say something online. TA can check it directly. You can receive the bonus for the presentation. So, maybe you can pass on this, it can be seen, so no problem. So you just hold it.
Our group is discussed for the first one.
First one, yeah.
1, 0, and 0. This y1 is 1, 0, 1, and 0 equals 4. And the output is 1.
Okay.
And the y2 is 0 and the
0.
0 equals 4. And the y2 output
0.
is 0.
So one is correct?
Yes.
Okay, good. Okay, thank you. So this is the presentation by Group 1. Actually, it's true. Alright, so next time if we use partly, the presenter should use your account so TA can check name or maybe student ID or name here, and then TA can collect the points for you. So it won't be necessary to mention, oh, I'm the presenter. Alright. So that's it, good too. You want to share your content? Good too.
Yes, but there's the picture is wrong.
Okay, it's you, right? It's you, right?
And I noticed a mistake.
It's your name?
Yes.
Right, wait a moment. Oh, you have two.
Yes.
But maybe you can remove one.
This is X or not just or, so.
Okay, this one. You
This
want
is
it?
the wrong and this is the right one.
Later you can remove it. Let me remove it for you. So wait a moment. Wrong, right?
Yes.
Delete.
Yes. Thank you.
Is it okay?
Okay.
So where speak louder. You hold it. 不用太高兴。
Okay. So we have the original state of 0 and 1, right? And the input is 1. So the y1 is x, x or d1 d2. So it's 0 because it's x or n and our q1, so it's 0. And the y2, the output is just x, x or d2. And the result, because it is also q1, so it's also 0. And the state, because new d1 is just the input, so it will be 1.
1-0, right?
And yeah, this is an O1, and it should be 1. And after
Shift.
yeah, shift. And the D2 is just D1 shift. D2 is, and it will be 0.
So
it will be
same as the original.
1, 0.
So I just want to make sure same as the results on the flow chart.
Yes, yes.
Okay, good. All right, thank you. So here it's the result checked by good too. So finally, you can check all. So we have the possible state transition. And so that we have the state diagram. Right? So here the state transition, we have D1, D2 first, and Y1, Y2, and here is our input. So we have the output. So is it okay? So that's it. This is the state diagram to have the So this is a state diagram to describe this. Right? Let's say it's next time. Should we have all the details? No. Instead, we can have these. So instead we have these. Someone like, oh, we designed the encoder. And this represents all the operation of the encoder. So it will be necessary for us to have the others. Alright, so this is the first one. State diagram. And we can pass on state diagram to have the next one. This one, tree diagram, to show the results. We can have the construction of the tree. And then we can have the results. Right? For the tree diagram, yes, take a picture for even you know this, but take a picture for this. Alright, so if we are showing, we have the state diagram. So can you construct this? Initially, how about timing 0, timing 1? And so that we just focus on timing 1 and then can we have the remainings? So check a few. Maybe check to this level. So check for 2 bits. If everything is okay, then this is the tree diagram. Now you have 3 minutes for checking. So ask you to check example 1 to the curve 1. So 1, 2, 3, 3 bits. So check 3 bits, can you have the corresponding results? If yes. Maybe you can check O1, is it true? So if this is 1, then this is output, and then 1 and this is output, 1 and this is output. So use the stat diagram to have the result. Can you have it? So check the correct for the tree diagram. You need to pass on the stat diagram first. Or maybe you can pass on the original one. It doesn't matter. But once we have the stat diagram, it's easy to pass on stat diagram. So that's why I ask you to check through the stat diagram. So later, I won't have the paddling, but I will not have some to check. After checking if it's okay for you or not. So let me check. You agree now? Right? Okay for this?
Not yet.
Not yet?
No, yes.
Okay. And Doria, right? Doria, okay? Oh, not yet. And Jen, okay? You, steady, you repeat your name again. Me. So, previously you have a pause and then pause and identify the people. Okay, I mean, the name on the list, right? Okay, fine. I mean, TA can identify you, use the account. Okay, sure, no problem. What you mean, right? Alright, so ready? Okay? Sure, okay. And the Thomas? Fine. So get us okay for you, right? Alright, so maybe I check carefully, but you need to know you can check this. Actually, based on the stat diagram, it's easy to have the tree diagram. So I go to the next one. Trellis. Trellis actually it's a different way to represent the result. Trellis. What I mean is trellis. And teacher. Maybe I forgot to prepare a key term. Trellis actually, maybe in Chinese first, 就是林寨. So this one actually is trellis, right? Alright, it's a trellis. So this one actually is a new way to represent the stat diagram. But this time we show the stat diagram in type of trellis. So same, we have a 0, 0. And actually we will have change. Okay, so for this, and what's the possible stat? So 0, 0. Check your stat diagram. 0, 0. If we have a 0 and 1, then what's the output? The output is 0, 0. If we have a 0 again, right? Or maybe if we have 1, then we have a 1, 0, right? check the state diagram. Right? So we'll have these, but for the others, later we can check it further. So we just have two possible changes. And sometimes we can have the change among the 4 steps. And we can have the way to have the continued changes if we have the step diagram. But later we will check it further. So it doesn't matter, at least I just want to let you know it's a different way to represent the step diagram. But we show it in this diagram called checklist. Alright, so later we will check it. And up to now, let me make sure any questions. If no, let us take a rest.